So what we're working with is we are working with our i's still, but we're solving quadratics that are going to leave to I answers. So we're starting first with our quadratic formula. So let's write that over here up on the side. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we're going to practice using that first. So the directions tell us to solve the following, leave answers in simplest radical form. So I always like to make my list over here of what my a values, my b value is, and my c value. So what is our a in this first problem? 1. Our b and our c, 2. So we're going to go ahead and plug those into our quadratic formula. So x equals, I have negative, and then I plug in a negative 1 for my b. So what ends up happening with that? Turns a positive. Then plus or minus negative 1 squared minus 4 times 1 times 2 all over 2 times 1. So going through cleaning this up a little bit, so we got our 1 plus or minus. Let's figure out what we have under the radical. So negative 1 squared minus 4 times 1 times 2. Negative 1 squared becomes 1. 4 times 1 times 2 gives us 8. And that's over 2. So then under the radical, 1 minus 8 would give us a negative 7. So I have 1 plus or minus square root of negative 7 over 2. So again, for that negative 7, I'm going to separate it into negative 1 and 7 all over 2. There is no other perfect square that goes into 7. 7 is a prime number. And that negative 1 turns into a what? An I. So we get x equals 1 plus or minus I radical 7 all over 2. And that ends up being our final answer. We can't reduce that anymore. So let's take a look at our next one. So again, I'm going to make my little list. Our a this time for problem number 2 is in 18. Our b is a negative 24. And our c is an 87. So we're going to get some large numbers here. So again, when I plug in the formula, my negative 24 becomes a positive 24. And then I have negative 24 squared minus 4 times 18 times 87. All over 2 times 18. Bless you. Okay, so let's figure out what we got under the radical. So I got negative 24 squared minus 4 times 18 times 87. So literally everything I just have under the radical gives us a negative 5,688. And that's all over 2 times 18 gives us 36. Alright, so now here's the hard part. We have to figure out, is there a perfect square that goes into 5,688? I'm guessing there probably is. Let's find out. 5,688. Let's try to divide by 4. Okay, well, at least 4 goes in, so we know at least 4 works. I'm going to keep trying to see if I can find a bigger one. So let's try by 16. Nope, 16 doesn't work. Let's try 9. Oh, 9 works. Maybe there's a bigger one still. Let's try 36. Oh, 36 works. Do we think there's going to be a bigger one? Somebody said 40. Nope, 49's a no-go. Let's try 81. Nope, 81's a no-go. Let's try 64. Nope, 64 is a no-go. Let me see here. 150 by 2. What do I get? Yeah, no, it's going to be 36 and 158. It's 36 and then 158. Alright, so again, the negative 1 is going to turn into an I. The square root of 36 turns into a 6. So we have 24 plus or minus 6I radical 158 over 36. Yep. All three of those numbers outside of the radical can be divided by 6. So that'd become a 4, that'd become a 1, and that would become a 6. So our final answer would be 4 plus or minus I square root of 158 all over 6. Alright, let's see if you guys can try that third one. Let's give you a couple minutes. Have you start that one. Alright, did you guys get negative 3 plus or minus I radical 7 over 4? Yes! That means we all did it right. Alright, good deal. Let's take a look at our back. Alright, so solving equations with i's, not using just the quadratic formula. You can do factor by grouping. We can use completing the square, extracting the roots, all that good stuff, and you can still get i's in your answer. So for the first one, they want to know what are the roots of the equation. So I gave you this nice little hint over here. Roots means find the solution to the equation here. So looking at it, do you think we're going to be able to factor this? What multiplies to give us 5? 1 and 5. Is that going to give us a 2 in the middle? No. So looking at this, we're not going to be able to factor it. I'm going to go ahead and I'm going to use completing the square because I'm personally a big fan of completing the square. So I'm going to subtract my 5 over and add a space on both sides of our equal sign. So I have x squared plus 2x plus a space equals negative 5 plus a space. So now who remembers, how do we get the number that goes in our space? Seth? Yeah. So we would do 2 divided by 2, which would give us 1. And then you square the 1, so our number for the line is going to be a 1. So now we can factor the left side over here. That would factor into x plus 1 squared. I know it's going to factor that way. It always factors that way for completing the square. And that's going to equal a negative 4, because negative 5 plus 1 gives us negative 4. So then I'm going to take the square root of both sides. So I get x plus 1 equals plus or minus. The square root of negative 4 would turn into a what? Not 4i, 2i. And then our last step would be to subtract our 1 over, so we get x equals negative 1 plus or minus 2i. Alright, let's take a look at our second one. We got 4x squared plus 98 equals 0. So I'm going to try getting my x squared on its own. That's what we call it by our extracting our roots. So I'm going to subtract my 98. So I get 4x squared equals negative 98. Let's divide by 4. What do we get? Negative 24.5. Let's change that into our decimal form. What is that as a as a fraction, I mean? No. No. As our fraction, that would be, wouldn't it be 49 over 2? And it's negative. That's a pretty thick negative sign for me, but that's negative. So now we'll take the square root of both sides. So I would have x equals plus or minus the square root of negative 49 over the square root of 2. What does the square root of negative 49 turn into? 7i. And then can we leave a radical 2 in our denominator? No, so we got to rationalize this. So I'm going to multiply top and bottom times radical 2. So 7i times radical 2 becomes 7i radical 2. And then radical 2 times radical 2 would just be 2. And that ends up being our final answer because I can't reduce the 7 and the 2. They want to know what are the zeros of P of m equals m squared plus 1 times m squared minus 4. Again, your hint over here, zeros, is another way of saying what is the solution. So we're trying to find the solution here. Now they've already factored it out for you by giving you the m squared plus 1 and the m squared minus 4. So don't multiply that out because that's just going to make your life a little more difficult. Let's set both of them equal to 0. So m squared plus 1 equals 0, m squared minus 4 equals 0. I'm going to take care of the m squared minus 4 first because I think that one's going to be the easiest. So we add our 4 over. So I get m squared equals 4. And then we take the square root of both sides. So m equals plus or minus 2. So we got two answers there. We got positive 2 and we got negative 2. For the other one, we're going to do the same thing. Bless you. So we're going to subtract our 1 over first. So I get m squared equals negative 1. And then take the square root. M equals plus or minus. And then that's going to turn into an I because the square root of negative 1 is our I. So there's the other two answers. So we got I, negative I, and then 2 and negative 2 are our 4 answers for that problem. Alright, so we got 2 more on here. So first one, I got 4 terms. So how are we going to solve this one? Yep, we're going to do factor by grouping. Let's group the first 2. Group my last 2. So what is our GCF within the first 2? Very good, x squared. And then we got x plus 4. Our GCF within the second 2? 4. And then we have x plus 4. So what we're going to do is we're going to put our x plus 4 first. That's our GCF now. And then we have x squared plus 4 goes in parentheses after it, the 2 things that we pulled out. So when we set them equal to 0, on the one side I get x equals negative 4. The other side I would subtract my 4 over, so I get x squared equals negative 4. And then we got to take the square root. So we get x equals plus or minus, what is the square root of negative 4? 2i. So there's our three answers for that one. We got a negative 4, positive 2i, and negative 2i. Alright, then taking a look at our last one. This one's a trinomial factor because I've got 3 terms. It still throws some people off because it's x to the 4th and then you got an x squared there. That's not grouping, even though a lot of people want to do grouping. That's our trinomial factor. X to the 4th, we would break apart into x squared and x squared. You just divide that exponent by 2. So then we're looking for what multiplies to give us 9, but could add or subtract to give us an 8. 1 and 9. To get the negative 8, you would have to have the negative 9 and the positive 1, because then negative 9 times positive 1 is negative 9. Negative 9 plus 1 gives you your negative 8 in the middle. So in setting both of these equal to 0, I would add my 9 over, take my square root, and we get plus or minus 3 as 2 of our answers. Plus 3 is one answer, minus 3 is the other answer. On the other side, we would subtract our 1 over, take the square root. So we get plus or minus I as our answer for that side.